Good morning, everyone. Welcome to Software Engineering. I'm Zhang Shuang from Software College, Northeastern University. Today, we are going to learn object-oriented analysis, dynamic modeling. The product of dynamic modeling is state diagram. Well, state diagram is replenishment of class description. It depicts all the states that a class instance may experience and the causing events. An event may be a message from another object or meeting some conditions. And an event may be an action which causes state change. The state change is called transition. Well, not all classes need state diagram. Some classes have clear state changing according to conditions and events. So, during the phase of dynamic modeling, we should achieve the state diagrams for such kind of classes who had clear state changing. Exercise 1. Draw a UML state diagram to model the control program for portable CD player. It should include 3 states: stopped, playing, and paused. Also include 3 events possible in any state. Pause is priced, stop is priced, and play is priced. We can get the state diagram for CD player like this. This is the start. Okay. So the initial state of CD player is stopped, and once the button of play is pressed, its state will change into playing, right? If the stopped button is pressed, the state will change from playing to stopped again. If the CD player is playing and the button pause is pressed, its state will be changed to paused. Well, if the pause button is pressed again, the state of CD player is changed from paused back to playing again. And this notation is for the ending. You can also take the state of stopped as the ending state. So this is a state diagram for CD player. Let's take some more cases. This case is for a book in a library management system. We understood that book has some states such as available, borrowed, and reserved. Some events may cause the state changing, including borrow, return, reserve, cancel reservation, reservation times out, and renew. Since we are quite familiar with library management system, it will be much easier for us to understand this state diagram. Okay, the initial state of a book is available. So once a book is available, it can be borrowed by anyone, right? Okay, so let's say someone borrowed the book. That means the event borrowing happened, and then the book state changed to borrowed. Okay, it changed to borrowed. Well, if the book is returned, that means the return event happens. The book state will change back to available. Of course, if the borrower renewed the book will remain the status of borrowed. If the book is available, it can also be reserved. That means someone wants to borrow the book, but he cannot come immediately. Maybe he will come to borrow the book tomorrow. So he can reserve the book first, just in case the other will borrow the book. So once the book is reserved and the book state is changed to reserved, if the book state is reserved and after times out, if the book is not borrowed, the book's state will change back to available. Let's say the book can be reserved for 2 days only, but in 2 days, the borrower doesn't borrow the book. Then in 2 days, the reservation will time out, and then the book state will change from reserved back to available, and then the reservation will be cancelled. Or maybe the borrower will cancel the reservation by himself. Then the book state change from reserved to available. If the borrower borrowed the book reserved by himself, the book state changed from reserved to borrowed. This is the state diagram for a book in a library management system. Okay, it's really quite easy to understand it. Next exercise, order. Order in an eShop system. An order goes through the state of placed, paid, shipped, arrived, and closed. Initially, the order is placed, and then the order is created, and its state is placed, and it is supposed to be paid. Once the customer pays for the order, and the state of the order will change into paid. Once the order is paid, the seller will deliver the product, and then the state of the order will become shipped. Once the product arrives at the destination, and the customer have received the product, the state of the order will become arrived. And then the customer is supposed to confirm the arrival of the product on the system. So once the customer confirms the arrival, the order state will change to closed, and then it ends. So this is the state diagram for an order in an eShop system. The previous cases are quite simple, actually. So let's go back to the case of elevator. Okay, so actually elevator will have quite some states, such as idle, door close, door open, stop, run, moving up or moving down. And then some events or some conditions may cause the changing of states of elevator. So let's read this state diagram for elevator together. It starts from idle. So now let's suppose the elevator is idle. Now this elevator is required, and then its state changed to run. Now the system will check the current flow of the elevator and the desired flow. Desired flow means where the request comes from. Let's say current flow is floor 1, but the desired flow is floor 7. So now the request comes from floor 7, and the current flow is 1. So this condition is satisfied. Desired flow 7 is bigger than current flow 1. Then the elevator state is changed to moving up. And then the event is move up the elevator. And then the current flow may change from 1 to 2 to 3 to 4 and so on. 2 is smaller than 7, 3 is smaller than 7, 4 is less than 7, and 5, 6. So this condition is satisfied until current flow is 7. So that means the elevator will keep moving up. And once the current flow becomes 7, and the 7 is not less than 7, this condition is not satisfied. And we find that here, this condition is satisfied. So the elevator state changed to stop. So that means the elevator arrived at the destination, stop. And after tamping out, okay, the elevator door will open. And another time out, the door will close. If no more requests, the elevator state will change to idle again. But if there are more requests, the elevator state will change to run again. So now let's assume the elevator is on floor 7. But now a new request comes from, let's say, floor 2. So current flow is 7, desired flow is 2, and this condition is satisfied. 7 is bigger than 2. So the state of the elevator will change to moving down. And the current flow is 7, moving down, and 6. 6 is still greater than 2, right? Okay, and 5, down, 5 is still bigger, and 4, 3, down. So finally, the elevator arrived at floor 2. And now the current flow is 2. Okay, the desired flow is 2, 2. So this condition is not satisfied anymore. So come here, this condition is satisfied. The elevator arrived at flow 2 and it stopped. And then timed out, the door is open. Another timed out, the door is closed. And then it will check any more requests or not. If no more requests, the elevator will stay idle again. Otherwise, it will keep running. So you can see that basically the state of the elevator just changed in a loop. Now you understand that some classes really has their state changed. That means the instance of this class may change during the process of business flow. So if such kind of things happen, you should achieve state diagrams for such classes. So that means some classes may need state diagrams, but some don't. So this is dynamic modeling for OOA. Okay, thank you.